Okay, hello and welcome to this first session on week one contents of ML practices course. Uh, I hope you've taken a look at the contents and watched the videos. Um, any questions before we proceed? So, okay, before that, let me tell you what we are going to cover in this session. We'll be first taking a look at the collabs that were used in recording the lectures. So we encourage you to write your own codes. So videos probably might miss out on a few instructions. So that's why we've been following this practice of running through the collab so that just in case you something is missed out, you can get back and see the code and do it at your own end. So I'll run through the collabs and then we'll move on to the activity and practice questions. In the end, we'll also code a few things to be able to answer the practice questions. So before we proceed, any questions that you would like to ask about this course or week one contents or in general anything? Okay, I hope you have started taking a look at the contents anyway. So you may please keep asking me questions as we go along. So week one in this course contains primarily three things. One is we are covering an end-to-end ML model building. So uh, so first five videos, if you see, they focus on how we can build an ML model and various details to it, how we can pre-process, we can explore the data and then pre-process and then build different models and then see how they fare and then how we can improve those models further. So pretty much all the steps that are generally followed in model building are being covered. And if you feel overwhelmed by all that is covered in the first five videos, um, don't worry, because that's just an example to show you how we generally proceed towards building an ML model, and all the subsequent all the parts of whatever is covered in the first five videos will be taken up one by one in the forthcoming weeks. For example, we are discussing pre-processing techniques in the initial few videos here in this week, and your week two will be on pre-processing, and then next will be linear regression, and then other regression models, and then ensemble models, and then classification techniques. So all these weeks are going to cover each and every library in detail. We're going to see what the parameters are, what their default values are. So we are going to get in depth in the subsequent weeks. So what we are doing in week one is to just give you an idea. So we'll run through what we have covered there, and you don't need to get into detail of each and every library that we are using in this week. So second thing that we are covering, other than this end-to-end ML model, what we are covering in the sixth video is an introduction to sklearn, because I hope this is clear to you that in this course, ML practices course, we are going to extensively use different libraries from sklearn API. So it's a brief introduction to sklearn, the sixth video, and after that comes data loading. So data loading is something that you are expected to be practicing in this week. So that is something that you should focus on. So I gave you an idea, the three components of this first week. Now what we are going to do is we'll run through the first collab, which pertains to the initial five videos. So you may please keep asking me questions if you want, because because it's a huge collab and I'll be running through it just sort of to show you the snapshot of all the code, so that if you wish to do it at your own end, you have all the code. Okay, so what we are doing here, uh, in this example, demonstration, we are taking a wine quality data set from UCI, and we are building different models, and then we are improving upon those models. So we talk about different steps in model building. This is, the domain knowledge. What is it that you're going to build? And then for that particular thing, you obviously need the data. And the next step is to explore this data. How do you explore? You use different functions from NumPy, Pandas, and Seaborn, Matplotlib you use to visualize the content. So that's the next step. And once the data is prepared, once you visualize, you see what kind of pre-processing you might need. So you need to prepare the data for ML models. For that, you need to see how you should clean your data, how you should really prepare your data for any ML model. And once that is done, you build a model. Using that data, you train, and that's how you build a model. And once the model is built, you see how it fares, what is its accuracy, what is its performance. And after that, you would want to improve this model further. For that, you would fine tune different parameters of this model, which we generally call hyperparameters. So hyperparameter tuning is the next step to get a better model. And once that is done, you present your solution. This is what our model is, and that's what you release. And the last step is to keep maintaining your model. So these are the general steps that are there that you come across while you're building any ML model in real world. Okay.
Ma'am, I have a question.
Yeah, please.
Ma'am, why does the model require maintenance?
Okay, so maintenance, sometimes your data keeps coming in, right? So let's say you have some data, the client gave you some data, and you built a model out of it. But it may happen that after some time, you get more data. Okay, so maintenance may comprise of various activities. I'm talking about one, I'm giving an example of one here. So you might get more data. Let's say and in that case, of course, you might need to retrain your model, and it might become better when you get more data. Second thing is you might get some new things in the data. So that's called basically data streaming data. And for that, again, there are different ways that you can use. You can use partial fit or fit. So these basically you can retrain your model on the entire data again, or you can train your model chunk by chunk. So there are different ways to do that. So if you get new data, let's say it has some new classes as well that were not available in the previous data. So that's one instance where you might need maintenance of your model. Or another way out could be, let's say some new model has come up and you want to try that on your data. Probably that might perform better. So that also comes under maintenance of your model, or let's say system. Is that clear?
Yes, ma'am.
Okay.
Ma'am?
Yeah. Tell me.
Isn't there a automated third like for maintaining the data?
I'm sorry. Isn't there a what?
Automate, like suppose there is an inflow data, so our program or our project will automatically accept it. So like
Your voice is breaking a bit. So what I'm understanding is some automated way. Is it? Automated way for what?
yes, ma'am. For getting the data.
No, that might not be always right. It depends on the scenario. It's dependent on the domain that is giving you data. So it might not be same. You might not be able to automate the procedure of getting data. Data comes from different sources many times, and it might also happen that you were using some 10 features to start with, and with time you get some more details, and out of that extra detail, that extra data, you can take out some 3-4 more features, and when you use those features on your data, probably your model becomes better. So you may not be able to automate this, of course, right? You might not be able to automate, bringing in new data and then extracting things out of that. It might not be possible. Uh, is that, does that make sense, Patrick? Is that okay? Should we proceed? All right. Okay. So once, so how do we start with? Of course, looking at the big picture, what is the problem that we are trying to solve, and framing the problem. Okay, this is all theoretical part. I'll move on to the actual coding part now, because all this you can refer to in videos as well. So they're speaking in detail about all this. So a few considerations that you need to make before you start. Obviously, whether it is a supervised or unsupervised or reinforcement learning problem. So if you, whether you have targets available or not, you have to find some patterns using unsupervised learning. So that's the first thing. And once, let's say it is supervised, you need to ascertain whether it is a classification problem or regression problem. And then after that, whether there are multiple outputs or a single output. And the system need continuous learning or periodic updates. That this is something that I was talking about. So do you get all the data in one go and there is no possibility of getting data later on, or do you keep getting data? So accordingly you will build model, right? Like I was telling, partial fit or fit, whether you should allow a stream of data to come in, and hence you train chunk by chunk. So that possibility also you would like to know beforehand. And batch and online, so this is also pertaining to the thing. Online is when you keep getting data, and batches when you get all the data in one go. So once you know about all these parameters, you need to know what performance measures you should use. So that depends on whether it's a classification problem or regression problem. If it's a regression problem, you will use MSE or MAE. And for classification, we have precision recall, reference score accuracy, and there are few more as well, which we will study in detail later. So this is how we start with, and obviously the next step is to get the data. Now, in this process, you need to be well versed with certain libraries: Pandas, NumPy, Matplotlib, and Seaborn. These four libraries are the ones that you will need to explore the data. So it will be a good idea to be well versed with these libraries to start with. Here we are taking the data from UCI. This is the link. And then using pandas, we are using pandas pd.read CSV function in order to load this data. So this is how we are bringing the data in. And once that is done, you can use all sorts of data frame functions in order to explore this data. So here we are using head function, which gives first 5 rows of the data, and that gives us sufficient details just to start with. Like you can see the column names, which will become your features, and what kind of data is there, whether it is categorical or numerical. So you see here the data is numerical, so those kind of details you can quickly get. And then the features, this should be a part of the domain knowledge. That is, it should be given to you what different features mean. So this is the detail of the features, which you can actually go and get at UCI itself, wherever you loaded the data from. Now, once that is done, you can break the data. So what is it that you need? You firstly, so this is just the list of column names. I hope you know how to play around with the data frame object. If not, I would suggest you to please practice at this stage before we get into extensive use of these functions. So data dot columns, data is the data frame which we created by using this function. So data is the data frame. Data dot columns will give you all the columns, which is all these columns, right? And then what you're doing is all columns except the last one. So that's what this part is doing. And dot values. So basically this would be your all the features list except the last one. The last one we are keeping in this variable called label. So -1 refers to the last one. So this is how we are doing. Yeah, Kumar 9, you have some question. Please go ahead.
Yes, ma'am. One question was there. By default, should be the label on the last, or I can keep label anywhere?
Good question. Uh, it is not necessary. In fact, along the way, in a few weeks, you would come across the data where the target is the first column, not the last. It could be first, it could be last, it could be somewhere along the way, somewhere in the middle. So this should be told to you by the domain expert. So that's what I was telling you. There's some domain knowledge, domain information that is associated with every data. So it should be part of that. What is it that you're trying to predict? So that's something that should be given to a data scientist. Okay. So here, what we are trying to predict is the quality, which is the last column here, but it may not be so always.
Ma'am, I had a question too.
Yeah.
So do we always feed our data like as a feature matrix and a vector of labels to the model?
Yes. Yes. So, yeah, go on.
So like, is this like the general format in which like always we feed our data to a model, or like there are more formats too?
Yeah, that's a way to go about. So basically, if you talk about sklearn, how it accepts your data is like the first step is training your model using the training data. So we need to get the training data and the test data. We'll talk about it in a while, but since you asked, I'll cover it. So train and test data is something that we need. Now, what does the train data contain? The train data contain the features and the targets. Similarly, the test data will contain the features and the target. So all this combined is your feature matrix and your target column. So that's the way to go about. Given any data, we put it in this format of feature matrix, which is we call it capital X. This will contain the columns will be your different features, and of course the rows are your different data points, and your small y is your target column. So that's one column that will contain all the target values. So once you get data in this format, you break it into train and test data. So that's the standard way, because that's how you feed into any sklearn model object. Okay.
Okay.
All right.
Ma'am, one question more.
Yeah.
So what will happen when there is a multiple outputs? So we can.
Yes. There are models which handle multiple outputs as well. So your Y could be instead of a single column, it could again be a matrix. Okay. If let's say it's a multi-class classification, then let's say there are three labels, in a multi-label classification problem, then your Y will be a matrix with three columns. Okay. And accordingly, we'll use the right model which can handle multi-label output. Okay.
Yeah. So
Same goes
on the
for the question. Yeah.
yeah, so on the column, it can be anywhere. I can keep, or it is the mathematically affected when I choose particular column. Like that, first three columns should be the level, or the last three column will be the level, or this three column can be anywhere inside that.
It could be anywhere, because that depends on whoever is providing you data. Let's say the person who is
Okay.
providing you data has kept it somewhere in the middle. But then in that case, he should tell you, right? Because the data is coming from his side and he's the domain expert and he knows what these mean. Once he tells you that, then only you will apply the
Okay. Got it.
on that. So you need to know, this should be told to you. You cannot guess. In case you have no knowledge of the domain, you might choose a wrong column as the target. So the person has to tell you what is it that they want to predict. Okay.
Okay. And one more question was there. There was a one describe function in that, and how they automatically come to know that what is our the output and what is our the input.
What is your output and input? Is it no? What is your data? So this function you're talking about? Describe,
Uh,
right?
not describe. Can you go info? Sorry,
Info. Okay. Okay.
it is.
So it is telling you about all the columns. So what does your data contain? Your data contains, data variable contains all the columns. We have not done any splitting so far, right? So data.info will provide you information of all the columns in this data variable, which is a data frame. So you see all the columns right here. What is your doubt again?
One second, ma'am. Just I was running the program. One program was there where it was automatically telling that you have this level, and
What was
he
the
was automatically telling that labels as well as that. Okay, so info, the last, the D types in the info, it is telling that the last column has the int that much thing. So it is only info is telling about, it is not telling about that much my input and that is particular column is output. We are not getting
Yeah,
any.
yeah. It is not telling you that. It's just telling you the data type. It could be anything. This doesn't mean that this is going to be the output.
Okay, clear.
Okay.
It was coincidence, so it was coming like that.
Yeah, yeah. Yes.
Okay.
Ma'am,
Yes.
so can we conclude that in general, which column is a label is given by the domain expert, and also in some toy examples which are preloaded in certain libraries, there are certain properties which automatically tell which are labels.
Yeah. So are you talking about the data sets which are part of sklearn? So they will mention that this is the target. So all these details will be provided.
But in real world, the labels are provided by the domain experts.
Yeah, in real world, you see, it could be let's say I'm a data scientist and I am provided some data by some domain, let's say some physics domain, and assume that I have no knowledge of what is it that they're trying to predict. So they need to tell me, right? These are the features that we have, and this is something that we are trying to predict. So unless they tell me, I might not be, I might not know what they're trying to predict. So they need to provide me the column names which should be used as target. Okay. The
Got
SQL,
it, ma'am.
whatever sklearn contains a very standardized data sets, and of course they mention what the target is.
Thank you, ma'am.
All right, so I'll quickly run through it, and please stop me if you want any details, because anyway we are going to do all this in detail later on. And if we go in detail of this one collab, it will take many hours. So you can stop me if you want any details. Until then, I'll go on and sort of run through the code of this collab. Okay, so data.info is one method to get a sneak peek into the data, and data.describe provides you statistics, basic statistics of the columns, which you can see all these things it quickly provides you. So gives you some idea of the ranges of the data sets of the data columns. And next thing that you generally do is to see the kind of distribution that the classes have. So here, this is a multi-class classification problem, and the classes are captured by this quality column, and value counts function in data frame. It gives you how many counts of each class are there. So this quickly gives you an idea of the distribution of classes present in your data. So as you can see, this is a sort of an imbalanced data, because some classes are very less represented in this data. So it's an imbalanced data, and there are many techniques that you can further use to handle an imbalanced data. We'll talk about it in some later week. Okay, we'll go on, and Seaborn, we are making use to plot to make a few plots. And then histogram. Okay, this is presenting the same information whatever we got out of this. This was sort of tabular, and this is the plot of the same thing. So here also you can see that there is imbalance in the classes. And yes, any questions?
Ma'am, we are not fixing the class imbalance in this collab for this project, right?
Yes, we are not handling that. Yes.
Okay,
You
got
can
it.
do that. You can do that. So even don't stick to this whatever is covered in this collab. I think a few models are covered in this collab. You can go on and try out more models. You can try out different other possibilities of hyperparameters. Maybe you can get a better improvement in the performance. So you should basically try out different things. Not at this stage. I won't want you to get overwhelmed by whatever is this week is presenting, because again, as I said, this is just to give you an idea. Don't get bogged down by all the libraries that are going to come up, okay, because you will do them one by one. Okay.
Ma'am,
Yes, Shruti.
ma'am, so sir discusses something called stratified sampling for imbalanced data. So I was wondering what other measures you would take if your data set was imbalanced.
Yeah, that's going to come up. We'll talk about that. So that's about how to divide your data into train and test. The stratified sampling is used for that purpose. So handling imbalanced data, there are various ways. So sometimes what you want to do is, since you asked, let me brief you about it. So sometimes what you want to do is you uh, you pre-process your data in such a way that there is no imbalance, and that kind of data you feed into the model. Before feeding into the model, you make sure that all the classes are equally represented. So for doing that, there are different class imbalance handling techniques which you can use. That's something that we are not using in this collab, but you can do that. So stratified sampling is used here. That is used to divide the data into train and test. We'll talk about that. Okay, histogram hist function from data frame.
Ma'am, one more follow-up question on that. So,
Yeah, sure.
if you artificially create such that there is equal sampling of all cases, then wouldn't the model be learning wrong things, because that wouldn't be representative of the real population?
Okay, so it's not that always you artificially generate data. There are techniques like undersampling, oversampling. So in some oversampling cases, we do artificially generate data, but that data what follows the patterns available in the given data. So it's not that we are feeding in wrong information. The information that we're feeding in is actually based on what data we are getting. It's just that we are making it more pronounced so that model learns the patterns available. The other thing is undersampling, where we actually do not generate artificial data. We randomly choose. Okay, there are different ways to choose also. One of them is randomly choosing, where we choose, let's say we see whichever class is the least represented. Let's say that class has some 2000 data points and the other classes have more data points. So we choose 2000 data points from each of the classes, and that's the kind of data that we generate. So there is no artificial data here. It's just that we have downsampled the classes which had a huge representation. So that's one way. And this technique, of course, you can use if your data is huge. If you have already very few data points for your training, you won't go for undersampling, and that's where you go for oversampling. So you can see which technique works best for your given data.
But then, ma'am, won't that
Hello.
represented in the prediction as well? Because say if I had cancer and non-cancer samples, but I had only 2 of cancer and 8 of non-cancer, but then I sampled them equally as 2 and 2. So will my model not think that cancer is more common?
You sample to 2 and 2, right? 2
Yes, ma'am.
for cancer and 2 for non-cancer, right?
Yes, ma'am.
Yeah, after that. So firstly, you will not do that because 2 is too small, right? You won't do, since your data is already small in number, data points are already small in number, you won't go for undersampling here.
But ma'am, even if it was 2K instead of 2,
Okay. Okay.
Even then, my model will start to predict cancer 50% of the time, which won't be true because in the real population, it's only there 20% of the
Okay,
time.
our aim here is to make the model learn the patterns present in the cancerous cases. Okay, it's not okay. How many in real world? How many cancerous cases come and how many non-cancerous cases come? That's a separate story which will be used when the model is released. We are not concerned about that. What we are concerned about is the model should be able to learn the patterns present in the cancer and non-cancer cases. If cancer cases are very few in number, the model will not be able to capture those ones, right? Those patterns. That's why we increase the representation of those.
And ma'am, how would you how would you transition from training to deployment in that case?
How would you transition from
Training to deployment?
Sorry.
So you said that this will only be used in the training phase because the model has to learn the patterns. But then when you will deploy it, will you change the model in some way?
So you won't change the model. See, our motive was to make the model learn the patterns. And once the model has learned the patterns, we are not concerned about how many cancerous and how many non-cancerous cases come for testing. Okay, it should be able to do fine, given that it has learned the patterns. There are 2% cancerous cases and 98% non-cancerous cases, or there are 50% of cancerous and 50% non-cancerous cases. Doesn't matter to us, given that our model is trained, it has learned the patterns, right? So it shouldn't matter to us during the deployment how many cases come from which class.
Sure, ma'am. Thank you.
Okay, HIST is another way to get the sort of distribution that every feature is having. So you can play around, you can change the number of bins, and so you see that this distribution you're getting for different features that you have in your data. So this is a part of exploring your data. And moving on, we have to now create the test data, as I said. So in order to basically you have to split your data into train and test, and this is a function written manually. You don't need to do that. You can make use of this train test split from sklearn.model selection. So what this class does is, it given the data, it will split the data into train data and test data, and you will be able to specify how much you want to keep for testing and how much for training. So you will import this library, and this is to see the documentation for any class. Just put a question mark, and then so first you have to import it, and then you put the question mark and then write the name of the library, and you'll be able to see its details. Okay, this is how we use train test split function. You pass the data that has to be split, and then you specify how much you should keep for testing. So this 0.2 will mean 20% should go to test data, and random state you should give so that always you get the same results. So you get this train set and test set, which you can further go on and use. Okay, next let's we talk about stratified sampling. So as we see that it's an imbalanced data. So if you use this function, what will happen is the test data as well as the train data that you get might not have the same distribution. If you want that both of them should have the same distribution, you can make use of stratified shuffle split from model selection again. So there you can pass on different parameters, and you can see that you get the same distribution. We can show this as well. So basically, what we are doing is here you see. Okay, let's go back. So here we have a train set. This is our train set. This is your test set. And then you want to get the distribution. How do you get the distribution? You will see how many data points pertain to a given quality, and then value counts give you how many data points pertain to a given quality label, and then you divide by the length. So that gives you the distribution of the data in that particular data. So this is your overall distribution, which is given by data. And if you compare, you see when we use stratified sampling, you got similar distribution. Just look at the first and second column. It's similar. So that's what we want, so that our training data is representative of the actual data that is assigned to us.
I'm actually unable to follow like what happened in the table.
Okay, this is Python code. I hope you can do this kind of coding. So what
In
we
the table.
This table, okay.
Yeah.
All right. So this is the overall distribution which we got from data variable, right? Data variable had the entire data, right? So overall distribution is that distribution. So you see, these are your classes 5, 6, 7, 4, 8, 3. These are your classes, and this is the distribution. Total should be 1. Distribution of these classes in the given data. Now, second column is the stratified data, the data that we split, okay. And you see that this is more or less same, you see, and this third column is the difference between the first and second column, which is very, very minor, okay. And this is the percentage. I mean, that's you can you can ignore that. Basically, you focus on the first 2 columns and you see that they are more or less the same. Now, if you use random sampling, okay, in random sampling will not take care of the distribution of data. So you see, just look at the first column overall, and then this is the random sampling. This column you look at, if you compare, there is a good amount of difference, of not huge, but there is a good amount of difference in the distribution of the actual data as well as data that was randomly split, okay. So that's the difference between random sampling and stratified sampling. Okay, you can choose one, whichever you like, but stratified sampling is is something that is preferred. Okay, once that is done, we need to, again, a part of exploration of data, we need to visualize.
Ma'am, one question was there from the previous year concept.
Okay, yeah, tell me.
Yeah, so since taking sample from the random data is the very important part of the machine learning. So the stratifying that you are doing, so what is the logic behind that? Since we are using the Python model, so how will I come to know that how he's choosing the data? Suppose I'm not using the module, I just want to write my program. So
okay,
the basic, what is the basic idea of the choosing? Because there is a data sampling is the many variety. For example, some data sampling is very random in the nature, but it is certain possible that some data is also following the normal distribution like a curve. So in that case, I want to see that, okay, this particular point he is covering or not. So sometimes data is also following some particular functional curve, the data distribution. So I can use my manual way also to taking my personal, because once I'm using the Python module, which is the stratifying, which is the some already made by the someone. So it's certainly possible. I want my way.
Yeah, of course you can do it your way. So what you're saying is, instead of using this sklearn function, you want to do it yourself, correct? You want to write code by yourself to be able to achieve the same. Am I correct?
So taking the data, what is the logic behind that?
Yeah, we can talk about the logic, no problem. So I think I think this will be covered in ML techniques course as well, but no problem, we can talk about it. So, okay, let's say there is a coin, unbiased coin. What is the probability of getting head in unbiased coin?
So it is depend on the not 50-50 for sure. 1 second, the 50%, sorry, unbiased coin.
Correct. If I ask you to build a simulator to achieve the same, like let's say you run the code and you get either head or tail, okay, with a 50% 0.5 probability you get head, with a 0.5 probability you get tail, okay.
Yes.
How this is one one question. Another question is, on the other side, you have an unbiased, biased coin, which has a 0.8 probability of getting head and 0.2 probability of getting tail. How do you write code for it? Can you do that?
Yes, we can do that.
How would you do that?
So, for example, okay, so we know that 0.8% will come, the 80% will be the head and the 20% will be the tail in that. But we don't know actually if serially we will toss 1 by 1 to 100. We don't know the curve of the up and down. So, yes.
I want you to write a code to be able to simulate the same behavior. When you run the first code, it should give you head with 50%, 0.5 probability. When you run the second code, it should give you head with 0.8 probability. So what you would do is you can call a function, let's say a randint or something, I mean, to be able to generate a random number between 0 and 1, right? So if the number is, so if you have to emulate the behavior of the 0.5 unbiased coin, if the number is between 0 and 0.5, you give head. If the number is between 0.5 and 1, you give tail. Okay, that's how you emulate the behavior of an unbiased coin. On the other hand, if you have to emulate the behavior of a biased coin, what you do is, if you get a number between 0 and 0.8, you produce head. If the number is between 0.8 and 1, you produce a tail. That's how you achieve the similar effect. Okay. Now here, can you think of doing the same in this particular case as well, now that you have this distribution?
But one thing, ma'am, so that distribution idea came after that programming. In the tossing the coin, I was generating the output using the programming. But sometimes what's happened, output is already available by the natural way, by the practical way it is available. For example, I'm talking the total student marks in particular subject of a online degree. So what will happen if I will arrange all the student marks? It will follow the some curve, what I think. So it will follow the curve like a normal distribution.
Yeah, let's say that's a normal distribution. Okay, go on.
And then I want to find that some group of the student which can convey the entire the marks. So in that case, I can't choose particular. So I have to choose some student, the particular curve. So how that
one second. What you want to achieve is, you want to choose
yes,
who represent the same distribution, right?
Correct. So
basically, you want to perform the stratified sampling, correct?
Correct.
Now, okay, fine, you can do that, right? What's the issue?
So how do ourselves, instead of using the function which is the predefined by the pandas or something?
Yeah, you can hard code. I mean, you can do it from scratch, as I explained to you. So, let's say your data is, from the entire data, there's some distribution there in that data, and you want to, let's say, take the half of the data, and that should also represent you the same distribution, correct? Is that your question?
Yes.
Okay. Now you would know how many samples you should need from a given class, correct? You have the class distribution, as in you have the distribution of each class, correct?
Yes.
And every class would have some representation. Let's say your class 6 has 100 samples, your class 5 has some 100 samples, your class 7 has some 20 samples, and so on. Now, if you want 50% of the data, you want class 6 to have 50 samples, you want class 5 to have 50 samples, everything half, right? So that's
Yes.
the number of samples that you want. Now, out of all the data, how do you choose these many data samples following this distribution? Whatever coin toss way I told you, you can exactly use that. Can you think of doing that? So basically, you for every data sample, so let's say total number of samples in the data was 2000, and you want 50% of the data that should have the same distribution, which means you want 1000 samples to be having the same distribution. What you can do is you can start a loop from 1 to 1000, and at every iteration, what you do is you generate a random number and between 0 and 1, and if that value is between 0, okay, let's follow this table. If you basically find the cumulative sum of it. Do you understand that? 0.4 is the first, 0.4 plus 0.4 is 0.8, and then 0.93, and so on. That's the cumulative sum. Okay. Now, if the
Yeah.
random number is between 0 and 0.4, you take out a sample from class 6. If the random number is between 0.4 and 0.8, you take out the sample from class 5, and so on. Do you get the pattern?
Okay. Okay.
You
Okay.
can
So,
really do it from scratch.
okay. So okay, I will decide before the type of the class. It's decided by us.
Yeah, because you want the same distribution, right?
Got it.
You need
Got
to
it.
follow this. This has to be the input to your code, correct?
I will try to implement that. Okay.
Yeah, sure. You can start a discourse thread in case you have an issue. Okay. All right. For visualization, we are creating a copy of the data, and then we are using from Seaborn. We are using scatter plot. This is how you can see different classes. Of course, there are so many classes, so it's a little mixed up, but you get an idea. And then you can achieve the same thing using matplotlib as well. Plot, and then kind is equal to scatter. So these different ways will be covered, I guess, in the next week. All these different visualization plots that you can make use of. Okay, next thing that you generally see is the correlation amongst the features, and it's not a good idea to have highly correlated features because that information gets redundant. So you can check the correlation using the score CORR, this function from pandas, and this is the kind of these are the kind of values that you get. Another way is to use heat map from Seaborn, so it gives you colored representation of each correlation value, and you can quickly make out which features are highly correlated. So that's what you can use. And another way out is scatter underscore matrix from pandas. Okay, so okay. Yeah, so this kind of matrix you can get where you can see the correlation. You see these columns are representing different feature combinations. You can visually see the correlation here. Okay, once you visualize and explore your data,
Ma'am, in the scatter matrix, what correlation are you able to see? Can you explain how these are related?
okay, you see the sulfates and then citric acid, if they were highly correlated, these values, these points, dots will be something like this, right? In this particular data, we don't have very highly correlated features, so you don't see that. But you would have gotten the data points like this, something like this, in some linear fashion, which is not happening here, right? So you see that the features are not very highly correlated, which is good. Okay.
And ma'am, in the cases when they are plotted with themselves, why does the graph look like this?
Yeah, because there's no point of seeing the correlation between citric acid and citric acid, right?
Right.
So it's the distribution, basically. It's the distribution of data points, simply. This is not the correlation value.
Right.
And
ma'am,
one only, right? Yeah.
And correlated variables, always one of them has to be eliminated, is it?
Yeah, your model will not be affected if you remove one of them. In fact, it might get better because you have lesser features and your model might not be very complex. So redundant features, keeping redundant features is not a good idea. You can let go of them if they are very highly correlated.
Ma'am,
Right.
can we skip this part and only use the heat map for the visual representation?
Yeah, sure. You can see all these are different ways to get a sneak peek into your data to explore and get to know more about it. So that's okay. You can make use of whatever works for you. This provides you more information, of course, as you can see, right? So you can just skip this one. It's not necessary that whatever is being shown here, you have to use all of them. These are just different ways.
Okay, thank you.
Okay, next is to prepare your data.
Ma'am, I have a question here.
Yeah.
Are we going to cover these visualization tools in details in the coming weeks? Because I have some confusions.
Yes. In fact, what I was thinking was, see, last term we did not cover this collab like this because at every point you might get more doubts because that's something that you need to do in detail and that will come up later on. In fact, we can actually skip this part over here. So my idea was to just go through it and tell you the steps. Do not worry about the specifics of the code that is being used, right? Because that will actually confuse you. So in fact, let's not get into the details of the code and talk about the steps that are needed. And that's what you should be noting.
I just wanted to clear one thing from you.
Yeah.
Since we are using multiple libraries for visualization, how these libraries interact with each other. Suppose I am drawing a scatter plot. I can decide the size of the plot by plt.figure. So suddenly there is a matplotlib function that comes in and decides the figure size.
Correct.
But the plot is generated by SNS, I mean Seaborn. So how these things are happening, there is a confusion.
Okay.
That needs to be clear.
Okay, no problem. So C1 library is built on top of matplotlib. Okay. In Seaborn, you can just write one statement and you can get very complicated and appealing plots. But matplotlib provides you higher control. Basically, you get many customization, functions that you can use. And if you are plotting something from Seaborn, you can still use functions from Seaborn. Matplotlib. If you're plotting something from Seaborn, you can still use customization functions from Matplotlib. So you can use both of them.
Okay. Okay, and also this pandas visualization, like panda dot hist was a pandas data frame function, right? To manipulate the size of the plot that function generates can also be controlled by matplotlib function figure.
No, pandas you can't use. As I said, Seaborn is built on top of Matplotlib. So there you can use Matplotlib functions. Pandas, I would say, is limited in terms of the customization that you can do. But since you are, using pandas and you want to quickly see something, you can make use of some of the functions that are available there for plotting. But they might not be so detailed, and you might not do much customization there. That is limited.
Okay. Okay. Thank you, ma'am.
Okay, so next thing is to check whether there are missing values in the data, and we see that there are no missing values here. We make use of isAny function from pandas, and if there are missing values, there is a library simple imputer in sklearn that we make use of, where you mention what do you want to do with missing values. You want to replace them by mean, median, or you want to replace them by some constant. So all these features are there. We will do with them in detail in the next week. So once you handle the missing values, you want to see which kind of attributes, that is features, are there, whether they are categorical or numerical. In case there are categorical features, you need to replace them by some number by using either ordinal encoder or one hot encoder. So you can use different preprocessing based on what kind of data you have. Another thing that you can use is feature scaling. If your features are across different scales, like one feature is ranging from 1 to 10, another is ranging from 1 to 20 lakhs. So there is a difference in scale. So it's a good idea to bring them on the same scale by using min-max scaler or standardization, which is standard scaler. So once that is done, we have pipelines that we can make use of to apply different pre-processing. Yeah.
Why is scaling important?
Okay, so how do you find the distance between two data points? In several ML models, you need to find distance between two data points. Okay, and one of the ways is Euclidean distance. Do you know what that is?
Yes, ma'am.
What is the formula of that?
Ma'am, square of coordinate difference in coordinates, x-axis and y-axis.
Correct. So let's say your x-axis ranges from 0 to 1. The x values range from 0 to 1, and let's say your y values range from 1 to 20, 1 to 10,000.
Right.
Okay. Now, when you compute the distance between these two data points, which have x1, x2, sorry, x1, y1 and x2, y2, okay, the distance that you get is
Yes, ma'am.
highly influenced by the one which has higher scale, correct?
Yes, ma'am.
Right? So even there is a little difference between the difference in the value of the x part, the distance will not be affected much. Why? Right? Whereas it should, right? Because the range of x is from 0 to 1, and there is some difference that has happened, but that difference is not able to make that much difference in this distance.
Right.
So that is why there are many ML models which make use of distance measures, and if that is the case and your features are on different scale,
Ma'am, which
your
all
model.
ML models use distance?
So k-means is there, k nearest neighbors is there. There are many models that use distance. Right?
Okay.
You find the distance. What is the distance from centroid? And
ma'am, scaling is standard scalar the only idea? Because I think the standard
there are
scalar.
there are many scaling techniques. They will be covered in the next week.
Is the standard scalar trying to convert it into a normal distribution?
Yes.
Ma'am, isn't that bad because the distribution that was there initially is getting lost?
See, generally, if you take huge amount of data, if you see the distribution, they are generally normal distributed. So you know about central limit theorem?
Yes, ma'am.
So following that theorem, generally when you take data in any real world scenario, it follows normal distribution. So there's no harm in that.
So, ma'am, everything that we are doing here changes if your data set is very small or very skewed.
I'm sorry.
So the entire process that we're using here changes completely if my data set is very small or very skewed.
If the data set is small, you cannot expect a good
right. Okay.
prediction, right? You need a huge amount of data to be able to make a good prediction.
Right. Got it. Thank you, ma'am.
Okay, getting back, pipelines are provided in sklearn to be able to apply different kinds of pre-processing in one go. We'll talk about it in week 2. And next is column transformer. When there are different kinds of columns, that is features, some features are numerical, you want to apply different pre-processing on them. Some are categorical. So there is a mix of features. So in that case, you use column transformers. Separate reprocessing on numerical and categorical features. And next step, once we have done the pre-processing, next step is to build the ML model. So here we are making use of linear regression, and so that you need to know which API contains that class linear regression, which is linear model in this case. And you create an object of that class and then you fit, which is equivalent to training. Okay, and for that you using the training data. This is your training data that we had created initially. And in order to evaluate the performance of model, you use mean squared error, or there are other ways as well. So we are checking mean squared error here. Yes, Abhishek. You have a question, Abhishek? All right, never mind. So,
ma'am.
Yeah, tell me.
Ma'am, is it not a classification problem?
Yes, it is. So what we have quality labels. So the labels are ranging from what were the ranges? 3 to 6, 3 to 9, right? So we are just trying out different models. So you are considering, when you are applying linear regression, you're considering it to be a regression problem, but you can apply classification models, of course.
Well, that's why like it has a high error rate, right? 0.42 error.
Yeah, error, how much error is there? So mean square error is 0.39. Yeah, 0.42 is mean square error here, correct?
This would actually mean like 42% error, right? Because it is scaled,
Yeah,
the data is scaled.
No, this is not percent. This is mean squared error. So when you see accuracy, that you can say 42%.
Okay.
This is not a percentage, okay? Because this is mean squared error. Okay, and that was your training error, and now this one is your 0.39 is your test error. Okay, and is there any question?
Ma'am, Abhishek here, ma'am.
Yeah, tell me.
Yeah, ma'am, can you tell me, actually my mic was not working at that time. I was going to ask about that pipeline function which we were using. Can you tell a little bit more about that pipeline function?
Just for the time being, you should know that pipeline is an object that helps you apply different pre-processing techniques in sequence. Okay, the exact usage will be explained to you in the next week.
And what is what is the purpose of this fit function, fit and transform?
Okay, fit function is used to train. So fit function is same as training. Okay, so here what we are doing is, you see what we are doing. This is your test data. Okay, and whatever pre-processing you have decided to be applied to your data, that is whatever pre-processing you applied on your trained data, you have to apply on your test data as well. Okay,
Yes.
so that's
Yes.
what we are doing here. You need to pre-process the data with the same techniques, correct?
Okay.
That's what we are doing here.
Okay. So okay, ma'am.
Okay, so it's a general practice to apply different models on your data and see which one performs the best. So now we are trying decision tree classifier, and we are seeing how much error we are getting. Now here we're getting 0.0 error on trained data, which means it is overfitting. Decision trees are known to overfit. We'll talk about it in detail in week 9. So that's how we can try out different models and see how they perform. And we can also use cross validation. Again, this will be covered in the next week. So here what we do is we try out different partitions of train and test using cross validation. Okay, and another class is linear regression CV. So what we're doing here, we are using cross val score. So again, what cross validation does is it divides data in different partitions of train and test, and it checks the performance of the model in different partitions and then takes the average. So that's what we are doing here. And same we are doing for decision tree as well. And you see these different scores we are getting, and then we are averaging them. So we get a better idea by using cross validation. Similarly, we can use ensemble methods. Here we're using random forest regressor, and then we can see how much error we are getting now. So this is the general way to approach any problem. Now you see here, so far we use the default parameters. We have not done any parameter tuning. So that's the next thing that we can do, which is fine tuning the model, which we can do using grid search CV. Yeah.
Ma'am, can you tell little bit about underfitting and overfitting? Because I saw some questions in the activity.
Yeah, we will be talking about, after this thing, we will be discussing the activity.
Okay.
Okay, so in order to do hyperparameter tuning in sklearn, we have grid search CV, which we can make use of. And again, this will be discussed in quite detail in week 3. So what it does is it checks for different combinations of hyperparameters and tells which one of these combinations is performing the best. So you can get the best parameters and it will take some time depending on how huge your data is, and then it will provide you the best parameters which you can finally make use of. So that was one way. Another way is randomized search, which saves your time in the sense that it doesn't try all combinations. It tries only some combinations randomly chosen. So that saves your time. That's your randomized search CV. Again, we'll do it in detail. So that was pretty much the sequence of steps that is followed. And finally, we present the model to the client and then keep maintaining our system. So that was your end-to-end ML,
Ma'am, I have a couple of questions here.
Yeah, Sandeep.
One from the pipeline.
Yeah.
It says that the last operation in the pipeline should be a transformer, other should be estimators. I didn't understand that part. And the second part is what is a CV? What is the fold in cross validation? What do you mean? What do you mean by fold?
We will be talking both of these techniques, pipelines in week 2 and cross validation in week 3. Everything will be explained in detail. So if you have doubts even after sir's explanation, then you can ask in detail about these doubts. So at this stage, just to start with, in the first live session, it is not possible to cover.
No, I'll wait. Understood. I'll wait for the next week.
Don't get bogged down by all the things that are being used here. Okay. So, yeah.
One thing, ma'am, in that fine-tuning lecture video, I did not understand anything. Ma'am, is that a problem or?
No, it's okay if you don't understand anything. So in fact, you know what, it would be a good idea if we keep this towards the end, because by then you would, by then you would have understood the different techniques, and then you'll be able to quickly see the flow. But since it's a first week, the motive of keeping this in the first week was to just give you a general idea, not to worry you about not understanding details. So don't worry, you will eventually understand everything.
Okay. Ma'am, is this like creating a big picture?
Yeah, it's a big picture. Yeah. So don't go into the detail of all the things. It's just get the big idea. Just get to know the sequence of steps that is generally followed. That should be sufficient. Okay.
Ma'am, I was following the same steps that were there in these lectures, but while plotting this actual level versus the predicted level, my predicted levels were the axes were actually coming as float points like 4.5, 7.5. But in these lectures, I can see these are just the real numbers like 4, 7, 8. So is it possible to have different graphs?
Sorry, where was the difference? So actually the difference can come in, there is a random state that is used. So there are many functions that require random state. So if it might be possible that some functions which require random state, they were not passed the random state value. In that case, you might get different results. So that is possible. Don't worry about it.
Okay, thank you.
Okay. So let's move on with the first set of activity questions after the first video.
Ma'am, I have a couple of questions. What is random seed and verbosity?
Random state, right?
Yeah, random seed. Sorry.
Yeah. So as I said, there is a randomization involved in different techniques. For example, if a model requires a subset of features, okay, at every step it chooses, let's say decision tree is there, at every node it chooses a subset of features. So there is a randomization involved there, correct? If the random seed is different, then it will randomly choose different features at each node. Okay. And then if you run the same program again, the random values that it will choose will be different. So you'll get different results across different runs of the same code. That's why it's a good idea to pass the random state. When you do that, it chooses the same random values across every run. Okay. That's your random state. And second is verbosity. That tells you how much detail you want, how much intermediate detail you want to be printed. So it's not actually that doesn't affect your model in any way. So when the execution is happening, if you want to see some details, so that's what is given by verbosity. More the verbosity value, more the details will be presented to you.
Okay. And what does this
And
42 indicates
ma'am,
actually?
what was the 42 representing in the
Nothing,
random?
you can give any value there.
Okay, okay. So will that affect my model?
If you keep changing random state values, your results might differ.
Okay, ma'am. So means it will be affecting my kind of accuracy.
Yes, accuracy will be also be affected because let's say you're splitting and different values are getting selected in train and test, right? So that's one way. There might be other ways where randomization will make a difference, and accordingly your accuracy might also change.
Okay, okay, ma'am. Okay.
Ma'am,
Okay. Yeah.
just a general question about the course. Are we going to look into the skeleton implementations of these models, or are we just going to like overview them as an API?
We won't get into the source code of these libraries.
Okay.
We would understand their usage. We would understand what these parameters are doing, what the default values are, how is it that you should use them. That's what you will understand.
Okay.
Okay, data snooping. This is the first question activity set. So what is data snooping? So as we spoke about, the given data is divided into train and test. And we train our model on the train data, and the test data we keep aside. Why is it that we do it? So that our model is not aware of the data that is present in the test set. Okay, that is done so that model doesn't get biased from seeing what kind of data is present in test. So test data is where we are testing our model, correct? Now if the model is presented that test data and it learns some specific details of that test data, and whatever accuracy we get finally will not be representative of the actual accuracy, right? Because we might get different data when we are actually deploying the model. So that's why it's a good idea to keep one set of data separate as test data. When we don't do that, there is a bias that comes in that the model learns, and that's precisely what is called data snooping bias. Okay, so what are the options here? Data snooping leads to biased estimation on test sets, correct? Increases the risk of false positives. So what are false positives? Anybody?
Incorrectly judging is as a positive or the
Yeah.
true value.
Yeah, the model says it's positive class, whereas it is false. So that's that pretty much happens when that's highly likely to happen when the model learns makes some assumptions about test data. Basically, it is biased about test data. So that is why false positives may happen, because the model might say that this is going to be a positive class, whereas it might not be actually true when a new data is presented to the model. So therefore, data snooping bias might increase the risk of false positive. This should be wrong option, and this should also be wrong. So first two options should be correct.
Well, a question here that why not it increases the risk of false negatives? Because it might also be possible that while learning the pattern in the test set, it might result in the false negative in the actual situation as well.
Yeah, false negative might also be increased, correct? But that's not an option here, right?
Okay, I'm just asking from.
That's that. Yeah, generally you're asking. Yeah, that might also happen.
Okay, now another question based on the data snooping bias. We are specifically concentrating over the test set. Now, it might also be possible that whatever the training set is there, and if I am biasing towards the pattern in the training set, so probably it will give me overfitted kind of thing.
So can we say that that is also kind of a data snooping or not?
You can't say that is data snooping. You're saying that can we call overfitting to be data snooping, right? No, that's
Yeah.
not the right terminology to use. Firstly,
Okay.
you need to learn. See, the motive of modeling is to actually learn the patterns from the training data, right? That's our motive. We can't do away with that. But yes, we should not overdo it in the sense that it overfits, correct? So there's a stopping point where you should stop learning the little details of the training data. That's what you identify using hyperparameters. We can talk about it later.
Okay.
Ma'am, data snooping, is it like getting access to the test data during the model preparation? Or
yes. So let's say the model makes some assumption about test data. Okay, it takes a look at test data and let's say that is a sort of polynomial. Okay, and that's what it incorporates in the model. Whereas the new data that you might get might be linear and not polynomial. So basically, learning wrong things from test data is what leads to the bias. Correct?
No, ma'am. I just want to ask what is the meaning of snooping?
Okay, let's say I am the data scientist and you gave me some data, and there's some test data that should be kept aside, right? But I sneaked a peek into this test data and I saw some patterns that are available. And then when I was building my model, I used those assumptions, those patterns that I saw. That's how I built my model. But the new data that will be presented to your model might be different. So whatever assumptions I used from taking a look at the test data, which I should not have, I actually made the model worse. Correct?
Yes, ma'am. Yes, ma'am.
Okay. All right.
Thank you, ma'am.
Yeah, no problem. Next question. Which of the following statements are correct? Random sampling randomly selects k number of points, k percent points. So yeah, it's like we talked about test size, like 0.2. So that's 2%. So if you talk about sklearn, random sampling selects k percent of the points as the test set. Stratified sampling samples test examples such that they are representative of overall distribution, right? We talked about it. So this should also be correct. No, they should not be representative of training data. They should be representative of overall distribution. So these two should be the correct options.
Now, one question again, that here we are talking about the test sample as a representative of the overall distribution. Can we say the same thing for the training samples as well?
So actually, if you see if you use stratified sampling, the training distribution should be the same as the overall distribution, right? That should be our target. Correct?
Yes.
So eventually it will be the same, but that's not our motive. Our motive is to look at the overall distribution of the data.
No, means the training set, because from the training set, some portion of it we save it as a test, right?
No.
So can I say that training set is also a representative of overall distribution?
That's what I'm saying. You take out test data from the overall data such that the overall the test distribution is same as overall distribution, right? Okay. Eventually, the training distribution is also same as overall distribution, right? But that's not our motive.
Okay, our motive is to have a test sample representative of this one.
Correct. Our motive is to have test samples such that it is representative of overall distribution. Eventually, both have the same distribution. Training and test would have the same distribution.
Okay, yeah.
Stratified sampling gives us test distribution closer to the overall distribution. That's true. So we talked about it. A standard correlation coefficient value of 0.98 represents what? So standard correlation coefficient means Pearson correlation coefficient, which ranges from, can anybody tell me?
0 to 1.
It's minus 1 to plus 1.
Oh, -1 to 1. -1 to 1. Yes.
Correct. -1 to +1. So +1 means
Strongly positive.
Highly correlated.
+1 means a high positive correlation and minus
Correlation.
is high negative correlation, right?
Yeah.
So 0.98 should be strong positive correlation, correct? Why is it a good idea to create a copy of the training set? You remember we had created a copy. So we generally do it so that we don't inadvertently make any change in the data which we did not want. So it's a good idea to create a copy and then manipulate it, explore it, and do whatever kind of exploration you want to do it on it. Okay, this is the reason we don't want to alter the original data. Okay. Matplotlib and Seaborn are used for which of the purpose? We talked about it. They are
Data
used for
visualization.
visualization, correct. No linear correlation between features is demonstrated by which value?
0.
Correct.
0.
Heat map can be used to visualize correlation matrix, correct?
True.
We saw that.
Yes.
We talked about function dot is NA. Why is it used?
Option A, to
Missing
detect
values.
null values.
To see the missing values. NaN means not a number. So if there are empty cells in your data, they are replaced by NaN values by your data frame. Okay. So those values you can detect using dot is NA function of pandas.
So, ma'am, if there any text in the that will be also NaN, no?
Missing values, empty cells.
Okay, okay.
Which of the following methods are used to drop rows containing missing values?
Drop NA and drop.
Very good. So drop NA and drop. What is the difference between these two?
Drop will means drop the entire row. Drop NA will missing value only.
Yeah. So drop NA will drop the rows which have missing values. You can also mention columns there, like there's a parameter axis. If you give axis equal to 1, then it will drop all the columns having the missing values. So that you can see. Now how drop is different? For drop you have to mention which row or which column you want to drop. Okay. So here you have to manually give the rows and columns that you wish to drop. Here it will automatically drop the rows having the null values.
But ma'am, the question asks about removing missing values.
Right. So if I know that, let's say first, second, and third, okay, let's say first, 10th, and 20th row are having missing values. I have seen this out of my exploration using my code. Then I can drop them using this.
But that does not meet the criteria of the question, right? I have to know the rows and then only I can drop.
Yeah, I agree your confusion.
Yeah.
This directly does automatically, but this automatically doesn't do. This is sort of manually mentioned. Yeah. So in order to handle missing values, there is a library, there's a class as simple imputer in sklearn. We talked about it.
Yes, true.
Okay. Fit transform on ordinal encoder is used for which purpose? Can you tell me?
To convert text into the numbers.
Correct. Convert text to numbers. Correct.
Ma'am, can you elaborate like how it works?
All right. So let's
May
say.
I try, ma'am?
I'm sorry.
May I try?
Yeah, please. That'll be good.
Yeah, basically, our data frame, any processing is not possible in the text values. It will process only the numbers. So all the categorical variables we have to convert into the number, some kind of means 1, 2, 3 kind of representation we have to give, and that representation we can give through that encoder.
Yeah,
is that
for
clear?
example, we have a Sunday, Monday, Tuesday kind of thing.
Yes.
So how will it number them? Can you elaborate that? Like.
See, ordinal encoder is used when there is an inherent ordering amongst the values of the categorical feature. For example, higher secondary, senior secondary, graduation, post-graduation, PhD, right? You see there is an internal ordering amongst them. So you can use ordinal encoder and you can assign 0, 1, 2, 3 or something like this sequence to these values. On the other hand, if there is no internal inherent ordering like red, green, blue, there is no color superior to the other. In that case, you use one hot encoder. Okay, we will
So
discuss
should
all
we
this.
say they're just ordering, right? It is not truly converting text to number, right? So number will not have its own face value. It will be just an order, right?
Ordinal encoder, you're giving a number, right? You're giving a number to the string.
So when we say number, can we do like mathematical operations on that number?
Yeah, there is an ordering. So, you know, if somebody has done PhD and let's say the numbering that you're giving is 5, and let's say somebody else has done higher secondary and you're giving a number 1. So this 5 should be taken as a more value as compared to 1 by the model, which makes sense, correct? You can use them as numbers to answer your question.
Can I apply percentage operation on those numbers? Or can I apply
Why would you
scaling?
apply percentage operation on these numbers?
Means because it is a number, so for other numbers I can do those operations, right? For these ordered numbers, I think they are special numbers. We cannot apply mathematical operations on these. Means
Can you give me an example in this particular context? What kind of
for example, you are converting from kilogram to gram, right?
You can still do
Weight is there in kilogram.
You can do that. You can still do that, right? Because let's say, okay, one thing that you might do is scaling, correct?
Yes.
You can still do the scaling. You can still do that, and the ordering will be maintained.
Yeah, that is what my question was. So we can use them as mathematical numbers.
Yes.
Okay.
Next question is scikit-learn provides a pipeline class to line up transformation in an intended order. True?
True.
Okay.
Ma'am, for the previous question, if I may ask.
Yeah, go on.
So the question that he was just asking is, I think he's coming from the background of the nature of the number. It's cardinal, ordinal, interval, or ratio.
Yeah, that's exactly.
Basically, for interval and ratio type of variable, we can perform arithmetic operations. But because it is just an ordinal variable, addition, subtraction, multiplication, division may not be very meaningful. Can I say that?
See, in this case, you actually won't. That's what I was asking you. Tell me a scenario where you would want to do something like this. But then since he really wanted to apply some operation like that, so one operation that I can think of is scaling, which you might do to, let's say, all the columns of your data. And if you think of it, it won't harm. It won't create any problem if you apply, let's say, scaling, although the range is already very small and there's no need of scaling on this column, correct? There might be some 4, 5 values, 1 to 4. There's not a huge range to for scaling to be applied. But in case you do that, it won't create any trouble.
Right, ma'am. So scaling is not a problem, but should we be taking averages there? Is that allowed?
Why would you be taking an average?
Amazon reports an average rating on the products 4.6, 4.7. Zomato does.
You can do that. You can do that also. Okay. Right? I mean, there won't be any problem. I can't think of any problem that will be caused.
Thank you.
Can you go back to that question again? Just one thing I want to.
Yeah, which
instead of convert text to numbers, can I say like convert categorical text to ordinal numbers to qualify it?
Yeah, if you provide that, you can provide more details. Yeah, to avoid any confusion that you are having right now. Yeah,
right.
It would be better if you provide more details. Correct.
Okay.
Which of the following can be used as evaluation measure for regression model? Can you tell me which?
Mean square error.
Correct. Cross validation provides a separate MSC for each validation set.
Yes.
Is that correct?
True.
Is that clear to everyone? So as I said, it creates different partitions of your data, and for each partition, it will check the performance of the model. Okay. And the performance, let's say we're using MSC. So you get a separate MSC for each set. Okay. Building a model on top of another model is called?
Option B, ensemble learning.
Right. So what is ensemble learning?
So, ma'am, we can use multiple models and take their vote together to decide the conclusion rather than relying on just one model.
Correct. So in ensemble, again, there are two ways. One is parallel and another is sequential. So one way is, like you said, you use different models and take the vote. Another is you apply one model, you see where it was lacking, where it was producing error, you take that into account and then create another model which sort of handles the errors by the first model, and so on. You go in a sequential manner. So that's what your ensemble learning is.
Like we do boosting.
Yeah, that's your boosting, correct.
Ma'am, can you tell me a little bit about that parallel one which you just explained?
Okay, so parallel one is actually your bagging. So let's say it's a classification problem and you use some 100 decision trees. You use all these 100 decision trees to be able to make the prediction of the class, and then out of these, the outputs that you get from these 100 models, you take the majority vote. Okay, that's your bagging. So in bagging, you see you can parallelly execute these 100 models. On the other hand, if you talk about boosting, as I said, one model is there, and then whatever the first model is making an error on will be handled by the next model, and so on. So this is not parallel, this is your sequential.
Okay, thanks.
What is the remedy for underfitting? Anybody?
Less
Less
regularization.
regularization.
What is the correct? What is the remedy for handling overfitting? Let's say your model is overfitting. What would you do?
More data and less regularization. Sorry, more data and more regularization.
More regularization, right? So here, this is the opposite. You want to handle underfitting, so you would have less regularization.
Can you explain about regularization rate now?
So to give you an idea, so regularization, what it does is it penalizes whenever your model is learning from different features to a huge extent. That is when let's say if you talk about linear regression, if the coefficients are huge, then it will penalize. Basically, it will increase the error. You make a change in the formula of error. Like if you're using mean square error, you would add a term there so that it penalizes if the weights are huge. So in order to balance this out, the model will keep the weights to be lower. So that's what your regularization. And what it does is it stops the model from being complex. That is, it stops the model from learning the specific little details of your data. So that is to handle overfitting. But if your model is already underfitting, you would want to reduce the extent of regularization. Okay.
Ma'am, can you please briefly explain overfitting and underfitting?
Okay. Although this will be coming in some later week, but we can talk about it. So, okay. Let's say the data is something like this. This is, I hope you can see the data points.
Yes, ma'am.
And this is your model. Okay. Is it overfitting or underfitting? Can you tell me?
The red line,
Red line is the model.
Model, and those are the data. So it is, I mean, looking at it, it is going through the middle of the data, right?
Yeah. Is it overfitting or underfitting?
It can be neither. When it is in the middle.
It's not overfitting for sure.
It's underfitting.
Okay, now it is clear. Okay. So now you can tell which one is overfitting, which one is underfitting.
The second
Second one is overfitting.
This is overfitting.
Yes.
Okay, and this one is
Underfitting.
okay. Why?
Because in the second problem, the model is trying to calculate exact matching, and in the test there might be different problem, so it might not catch up the.
Okay, so you see these are your data points, not very clearly visible, but try to get an idea. So these are your data points, and this is our model, which is very simple and not complex. We should try to have not very complicated models. On the same data, we are having this model, which is very complicated polynomial model. And you see, it has learned the little specifics of the data as well. Whereas when you actually get the data in real world, that may not be the same, right? Because real world data has, noise. And this noise is also captured by your model. Let's say when your data is presented, the new data that comes in could be something like this. Okay. Now on this kind of data, if you use this model, there'll be huge error. Whereas this model might not be giving that much error. Okay. So it's not a good idea to learn for the model to learn the little specifics of the data, which actually may be due to noise. So in this situation, this might be a good model, or maybe if you want to go a little better, something like this. This is actually fitting well, but this one is like learning very little noisy details as well. So this is precisely your overfitting, and this is your underfitting, and this may be your a decent model. Okay, is that clear?
Yes, ma'am. Understood.
Okay.
So this is the reason why in the decision tree, I mean, when we are calculating the decision tree, we were getting in the training data set, we were getting the MAC to be 0, while
Good
in
question.
the test.
Yeah, go on.
Yes,
Go on.
ma'am. So yeah, so in the test data set, we were getting 0.5 with them. That was huge difference.
Yes, that was the reason. You see, decision tree something like this. Now that decision tree was on default parameters, and one of the parameters of decision tree is max depth. Okay, and by default it is none, which means go on and on until you get the leaves which have one node remaining, that you cannot further split it. Now that tree was grown completely, fully, such that it learned the noise as well. That is why it's a good idea to give a value for max depth so that it stops somewhere over here. Okay. So that's one of the disadvantages of decision trees, but you can handle it, right? You can mention a good value by hyperparameter tuning. You can find a good value for max depth. Okay. Tell me this one. Grid search CV is a part of which library? Very easy. Simple.
Sklearn.
Yeah. Which of the following are hyperparameters in random forest? Any idea?
Number of estimators, maximum number of features.
Good. So random forest is a type of bagging ensemble technique. So how many decision trees should be used is one of the hyperparameters. Each of these decision trees should use how many features is another hyperparameter. Okay. So this is something we need to tune. Initializing grid search CV with refit is equal to true option. Okay, this is a typo here. It should be retrain. Retrain. So in grid search CV, there is a parameter refit. When you give it to be true, what it does is, so I'll just give you a brief idea quickly, and so cross validation, let's say this is your data. Okay. in the first iteration, you would leave this data to be test data and this data should to be trained data. In the second iteration, you would, let's say, leave this data to be test and the remaining to be trained. In the next one, you should leave this data to be test data and so on. Let's say one more iteration. CV is equal to 4, this will be. Okay, you can mention a value for CV. So in the first iteration, this will be your training data, this much only. In the second one, this will be your training data. So when you do refit is equal to true, what it does is, in the end, whatever best parameters it obtains, we are talking about grid search CV. There are some best parameters that it gets. What it will do is, in this case, it will train the model on the entire data, in the end. So that's what this parameter makes a difference. You will get to know in detail again later on when we talk about grid search CV. But this was.
Can you repeat once? Sorry.
So when you mention refit to be true, after finding the best parameters, it retrains the model on the entire training data. That's all. Okay. For a large hyperparameter space, it is desirable to use which one? Can you tell?
Randomized search.
Yeah, why?
And because grid search CV is very much limited to what we supply as the input, right? We only look in the limited space that we've given.
No.
Randomized is going to take a wider range.
No, okay.
Then it will take less time.
Yeah. Yeah. So first answer was also correct, but not completely. So what grid search CV does is, it will try out all possible combinations. Let's say first parameter has 10 values that you want to try. Second parameter has 10 values. Third parameter has 5 values. Grid search CV will try out how many combinations? 10 into 10 into 5. Okay. 500 combinations it will try. If the data is huge, it will take a whole lot of time. Randomized search CV, what we do is, we give some value of max iter. How many iterations we should, how many combinations we should try? Let's say I want to give 50. So what it'll do is, out of these 500 combinations, it will randomly choose 50 combinations and will try them. Whichever gives the best, that will be given as the output. Okay. So if your data is huge, then randomized search CV may be preferred.
Ma'am, is it like stochastic that mini batch gradient descent problem we studied in the MLF?
Mini batch,
or some word was I'm not able to spell it out. Stock.
No, it's not. It's different. So all that we're doing is, out of all possible combinations, we are randomly choosing some combinations, and then we are checking them. That's all.
Okay, ma'am. Okay.
Ma'am, then it's a kind of trade-off situation, right?
Yeah, it might happen that the best parameters you missed out. It might happen.
Yeah,
Then you have
yeah.
a trade-off between the speed, right?
Okay. Okay.
So grid search CV will try all these cells, whereas randomized search might try these only. Okay. So if you might reach close, you might get the best one, you might reach the closest one. So it depends. Depends on how many iterations you're trying as well. Different types of sklearn objects are have estimators, predictors, transformers. Okay, transformers are used for pre-processing. Estimators are used for training. Predictors are used for predicting the values. Okay.
Madam, I had a question about this grid search. Suppose I have a total grid of 500 combinations, like you said. Then what is the optimal number of iterations I should go to maximize the probability of finding the best combination of hyperparameters?
In randomized search?
In randomized search, yes. I heard of this thing called the secretary problem, which maximizes the probability of finding the best candidate in a grid search, which is by dividing the total number of combinations by E. Is that a way to go when I using randomized search?
Which problem? Sorry, name the problem again.
The secretary problem.
Secondary problem, is it?
No, the secretary problem.
Secretary problem. Okay.
Yes.
So that tells you the number of iterations to try in randomized search.
Yeah, if I know the total number of combinations I have for grid search, total possible number of combinations, and to optimize the probability of getting the best combinations out of that, what will be the number of iterations I should go through the randomized search?
Okay, I don't know. Maybe we can check that out. I'm not sure. I've never applied that. So what we generally do is we try out some number that our hardware is able to manage, right? So given given the processing capabilities and the time that we have at our disposal, we use that many. We decide this parameter accordingly. So, but if you want to get an optimal number, maybe we can check this out.
I might, may I start a discuss thread on this?
Yeah, sure.
Okay.
Okay, predict method takes a feature matrix as an input and returns predictions. Okay, tell me which one is correct out of these. A is correct. Predict methods actually takes the feature matrix and returns predictions. Correct.
Yes, ma'am.
Then score method measures quality of predictions. Correct.
Yes. Yes.
Fit transform is used on test data. Is that correct?
No.
No. Fit
No.
transform method fits the parameters and uses them to transform the data set. Correct?
Okay.
Yes.
Okay.
Yes.
Okay. Linear linear model implements algorithms like logistic regression, linear regression. Correct. This is correct. K nearest neighbors is in sklearn dot k neighbors. That's it. Sklearn dot neighbors. That is different. Multi-class is different. Multi-output is different. So yeah, the only first option will be correct. Naive based classification is available in sklearn.naive underscore base. This one. There's a typo. There should be a dot here. Okay. So there's some convention that generally is followed by sklearn, like the API names are following snake case. So there are different naming conventions in Python. So everything small letters and then underscore. That's I think your snake convention, and then there is camel convention. This one is your camel. This is used for the class names. So you will get to see this along the way. Okay, next is we want to create synthetic data using make blobs, which is available in sklearn.datasets. And we want 10 samples, 3 clusters, 2 features. This is random state. So which of the following is likely to be the correct output? We mentioned 3 clusters, so there should be 3 values in Y. Here there are 2, 2, 2. Here there are 0, 1, 2. Okay, this should be the correct option. Okay, which of the following is supervised learning problem? Can anybody tell me? Okay, let's talk about the first one. Which kind of problem is this?
This is
Recommendation system problem.
Correct. Second one?
A categorization, classification problem.
Clustering, I think.
Clustering. You have to group them into 3 categories. Okay. You are only given the heights, not the labels. Third one?
The regression problem.
Supervised learning.
Classification.
Yeah,
Label is
correct.
present.
Correct. Third one is supervised regression. Fourth? Reinforcement learning.
Reinforcement.
Yeah, okay. Next question. Which of the following is regression task? First one is recommendation. Correct. Second one is, again, okay, this is the same only. Second is your clustering. Third one is your same option.
Regression.
This is regression. No, wait. This one is bank looking to recommend personal loans to its customers. Okay, yeah, this is regression.
Last one is should be the regression problem.
Last is also regression.
Last is also regression.
Correct. Predicting. So that's a multiple select. Predicting rainfall based on data available. Okay. This is also regression. Okay, which of the following is true? Regression that uses L1 regularization is called
Lasso.
Lasso.
L2 is called ridge.
Ridge.
So both of these should be incorrect. We need to divide into test and train. Okay. Why do we need, divide into train and test? We don't need to train on entire data. The training happens faster. No, this is not the reason. For ensuring that model has low bias and generalizes better on, okay, this is okay. It should generalize better on the unseen data. So we want to ensure that model has low variance and generalizes better on test. So last option should be correct.
Ma'am, I was confused between the third and fourth.
Okay. So what is variance here? So variance here is, let's get back to our same example. So when different kind of data is presented to the same model, what is the variance of error that you get across these different data? That is your variance. And what is your bias? Bias is the error that you get on one data on which you are training. So let's say if you look at this model, okay, forget this green model. Let's talk about the red model, the red one, this one, and this red one. These two models. This model will have low bias but high variance. Why low bias? Why? Because it is completely learning everything, right? So the error that you will get on training data will be almost zero, correct? Very low bias. Whereas it will have high variance, which means when new data is actually presented, like this blue one, there will be these many, squared errors. Similarly, when a new data set comes, it might be even way different, right? It could be somewhere over here. So again, the error that you get will be again huge. So variance in the errors across different data that this model gives is the variance that we are talking about over here.
Okay, ma'am. Ma'am means the variance is the means SME of the test data, and the bias is the SME of the trained data.
In a way, you can say correct. To get an idea, to have a rule of thumb, you can say that. Yes.
Okay, ma'am. Okay, ma'am.
Okay.
Thank you, ma'am.
Yeah. Which function is used for fully describing the data set? Tell me. What does shape do?
Ma'am, its last option is correct.
Yeah.
But
what does shape do?
Shape will tell the dimension.
Correct. Head will tell you initial
few values.
This is no function. This is correct. Okay. Sorry. Okay. So iris dataset, have you played around? So it's the basic dataset that is generally used when we are learning ML. So we are loading this data from sklearn datasets. Load iris is what we use. We create an object of it, and then feature names is what we are trying to print here. So the feature names in iris dataset, if you play around, I mean, I think there is a question practice assignment as well. When you play around with this data, you see the feature names to be petal and sepal properties, which is length and width. Okay, so sepal width, sepal length, petal width. No, this is wrong. First should be the correct option. You can actually code and see. I had planned to do this towards the end, but let's see. We do it today or in the next session. We will see.
Yes, ma'am. In the iris data, thickness was none of the dimension, and three
correct.
of the options thickness is given.
Correct. That's the thing. So first should be correct. With which of the following codes we can examine the shape of feature matrix? Any idea?
Second one.
Why?
That's the syntax. Data.shape directly works with the data frames as we normally read them. So with this library, when we load a data, it is data.shape.
Yeah. when you load the data from load using load iris, it returns you sklearn bunch object, which has two things. It's a sort of a dictionary, two things. One, first is the feature matrix, that is your data, this data. Second is your target. So data is the feature matrix, data.target is your target column. So in order to get the shape, the feature matrix, you'll write data.shape. First, four examples of feature matrix can be accessed how? Tell me.
Second one.
Second one. So colon, nothing before colon means starting from 0, and the last it goes up to last -1, 4 -1. 0, 1, 2, 3 will be QMS. Which of the following is true about openml.org? It's a public repository for ML data and experiments. No, it's not private. It allows people to upload their data. Yes, it does not automatically analyze the data. So these should be the correct options. First, A and C. Make blobs enables us to generate random data for clustering. So we talk about in this video, 7th video, we talk about data loading. There are different ways we can make use of. We can load sklearn data, toy data sets they are called. We can load data from some online resources using the link. We can load data from UCI, and we can generate synthetic data. So for generating synthetic data, we have make blobs, which generates clustering data. So this is true. Okay. So that was about activity questions. I had planned to show some code for practice, but I think that will be best done in the next session where we will do hands-on. Until then, it will be nice if you also practice from your side. And then only you'll be able to learn better. Now, if you have more questions, we can take, or we can close it if you're done.
Ma'am, in case of this grid search CV, we rather, I should say cross validation in general, K4 cross validation, we take an average representation at the end.
Correct.
What if the values were so different that they were outliers in that output performance, hypothetically?
Generally, yeah, we can talk about it hypothetically, but generally in practice, it won't happen. Why? Because the data is coming from the same source, and then you see how you're dividing the data like this. So something that is so what are we averaging? We are averaging the performance on this test data. Let's say P1 performance here, P2 is performance here, P2 is performance here, P3 and P4 are performance here, correct? We're taking the average of these. Now you're saying there might be outliers. P1 is very different from P4. It is very less likely. Why? Because this P1 is right now becoming a part of training, correct? I mean, they all are becoming part of training or test. So whatever you're training, you're testing on a similar kind of data in different iterations. So it's very unlikely that there'll be outliers.
Sure. Thank you.
Ma'am, can we always
yeah, sure.
Ma'am, can we always use stratified sampling instead of random sampling for the sampling data?
Yeah, you can use.
Okay. Thank you.
Any other questions?
So, ma'am, if it is preference is given to the stratified sampling, then what is the advantage of random sampling?
It's not that preference is given to stratified sampling. You can go on and make use of random sampling. Firstly, let's say your data is balanced.
Uniform, huh?
Yeah, all the classes have more or less equal representation. You don't really need to get into stratified sampling. You can do away with random sampling. Okay.
So, ma'am, there must be some kind of advantage in terms of the time or some kind of memory. in random sampling?
Advantage. Okay,
Yeah.
it will be quicker. It will be quicker, right?
Yeah.
Random sampling will
Less
be
time. Less time.
faster.
Okay,
Less
okay.
time. If your
Yeah,
data is huge, your stratified sampling will certainly take a lot of time. Correct?
Yeah, yeah. That's what I was asking.
Okay. If your data is sort of balanced, don't go for stratified. No need for that.
So first we have to check the data. If the data is uniform, then we have to apply the random. Otherwise, we have to apply the stratified.
Yes, exactly. So that's what we were doing in exploration of data in the beginning, right? You saw that.
Yeah, ma'am.
We were just playing around with data. We were just exploring it. That's to get to know more about data and accordingly applying the right techniques.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Okay. Any more questions? All right. If there are no more questions, we can close the session. It was a good interactive session. I hope you got you understood a few details. More we will do in the next session. Some hands-on we will do, and things will be more clear. Thanks everyone for joining in.
Thank
Bye.
you.
It's a good beginning, ma'am.
Yeah. We are also excited to have you on board and discussing things with you. It was a nice session indeed. See you all. Bye.
And all the session will be taken by you only?
No, there'll be different people.
Okay.
Yeah.
Okay, thank you, ma'am.
Okay. Thanks. Bye everyone. Bye.